Alright, we are giving notes over section 3.5, the graph scale change theorem. Scale change means multiplication. We're not talking about adding and subtracting like we did before with translations. We're talking about multiplication. So for instance, we have a pre-image, in this case just a coordinate, and we have a rule, a scale change rule. Yes, we'll use capital S, not capital T. That's what we use for translation. But it's going to take any point xy and it's going to do this to it. It's going to triple the x's and it's going to divide the y values by 2, or you can say multiply by a half. So in other words, this point right here turns into the point 6, 3 halves. Right? Tripled it. All we're doing is loading things in here for x and for y. And we can see what the point becomes. This would be considered the image of that pre-image using the rule. Okay? So what is the image? That question is asked, and it is the point 6, 3 halves. So let's just kind of review our generic rules of scale changes. A generic scale change looks like this. It takes any point x, y, and it multiplies the x value by some number, we'll call it a, and it multiplies the y value by some number, we'll call it b. That's a little bit different than our translation rule, which took x and y and added h, which is the horizontal shift, and added k, which is the vertical shift. So when you see a, b, h, and k, which is going to come up more frequently, especially as we continue to move through different examples, and especially into chapter 4, trust me, you'll be sick of hearing me say something about a, b, h, and k, if you aren't already. Anyway, so here's a function, a rounding down function. We could have any of the different types of parent functions. And we have a scale change rule, and we are being asked to apply that rule. So let's think about what we're going to, you know what I'm going to do here? I am going to throw in a 3 just for fun. So we have a scale change rule, 2x, 3y. That means we're doubling the x's and tripling the y's. What kind of words are we going to use? Like in translations, we use words like left, right, up, down, because those were the shifts. So we're going to use things like horizontal, vertical, shrink, stretch. Some combination of those will be used. In this case, this is a horizontal stretch by 2, and it is a vertical stretch by 3. Remember, the rule never lies. The rule always tells the truth, and so as you would expect, the steps are going to get bigger, and the gaps between the steps in the rounding down function are also going to get bigger because everything's getting stretched. So on the graph, we have a step that used to go from 0 to 1. So it used to go from 0 to 1, but now it's getting stretched by 2. So in other words, it goes from 0 to 2. Closed on the left, open on the right, because that's what the rounding function does. Well, if you do a vertical stretch by 3, that means that the jump does not take just 1 step up, it takes 3 steps up. And yet, the length of each step is 2 units long. So we could continue to do that, right? Jump up 3 steps. Close circle. Open circle. And of course that's going to continue down there forever and ever and forever up there. But that's what happened when we did a horizontal stretch by 2 and a vertical stretch by 3. So what does the equation of this image look like? Well, once again, this is the part you don't like. It's the part where we substitute in what looks like the opposite. So when it says 2x, in the place of the x in the parent function, we replace that with x over 2. Now we could have also said 1/2 x. That's also okay. And on the other side, we're going to have replaced the y with y over 3. Yes, we could have said 1/3 y. Now what does the calc-friendly form look like? The calc-friendly form looks like this. Well, multiply both sides by 3. So we replaced with the opposite. Now, let me just remind you that the rule states what I would replace this with so that we could get back to just x. If I put a 2x in here for x, the 2's would cancel, leaving me with just x. If I put a 3y in here, the 3's would cancel, leaving me just y. So the rule helps me know what I would replace to get back to the original. Yes, I know when you're writing your equation of your image, right? Your image equation being down here, you're substituting with what looks like it's backwards. If it said multiplication by 2, then we're dividing by 2. If it says multiplication by 3, then we're dividing by 3. Likewise, if you're multiplying by 1/2, you would be replacing with 2x, and so forth. So for instance, I see a graph that looks like this. Okay? It says, here's some graph, y equals f of x. Now, they didn't give it an equation because you can't come up with an equation for a shape that looks like this. I don't know any equation or parent function that works for this. This is just a set of 5 points, and they're all connected by line segments. So we'll call this a function because it does pass the vertical line test. So they want me to draw this. So what just happened? We have our pre-image and its graph, and we have the image, and we'd like to know what rule occurred. Well, if you replaced x with 2x, then the rule must have said x over 2. And if you replaced y with y over 3, then the rule must have said 3y. Remember, these are the things that I would use to substitute in here for x and y, which would eliminate the 2 and the 3 and get me back to the original. So the rule never lies, right? So this is a horizontal shrink by 1/3. Now, oh, sorry, 1/2. My apologies. When you use the word shrink, you are guaranteeing to me that the number that will follow it will be smaller than 1. If you use the word stretch, like we did in a previous example, the word stretch is going to be followed by a number larger than 1. So stretch indicates something's larger than 1. Shrink indicates that it's less than 1. And this is a vertical stretch by 3. So horizontal shrink by 1/2, vertical stretch by 3. Now we want to do this to the graph, see what happens. Well, it sure would be nice if I had a set of coordinates, because then I could just use the rule. So for instance, on my graph I had the point -6, 0. And I had -2, -1. And I had 0, 2. And I had 2, -3. And I also had 6, -3. Now if I use those points and my scale change rule, I'm cutting the x's in half and tripling the y values, then this point would become the point -3, 0. This point would become negative 2, negative 1, which cutting it in half, and tripling the y value, which would be negative 3. Cutting it in half, tripling the y value. Cutting that in half, and tripling the y value. Cutting that in half, and tripling the y value. Okay, just following the logic of the scale change rule. I'm going to use my coordinates, and I'm going to draw a box around the coordinates if I can. Whoa, 3, negative 9 might be a little tricky. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, didn't plan that one all too well. Oops, I said I would do boxes. 1, negative 9. And 0, 6. And negative 1, negative 3. And negative 3, 0. That's the new set of points. Okay, what happens when you take a point xy and you reflect it across, let's say, the y or the x-axis? So, reflect across x-axis. Alright, doesn't that mean that we have a negative y value? So this would be the point x, negative y. I'm going to kind of speed things up here. Well, I'll let you do one thing here at the end. So a reflection across the y-axis would be the point negative x, y. So what I want you to take from this is when you apply a negative to the y value, you reflect across the x-axis. And when you apply a negative to the x value, you reflect across the y-axis. So we can use scale change rules, and I can ask you to do descriptions of things like this. And you would have 3 things to tell me. So I want you to list 3 things that you see here. One of them involves the 1/4, the multiplication by 1/4. One of them involves the 2, and one of them involves this negative 1. So there should be 3 things that you tell me about this. Something about a reflection, something about a stretch, something about a shrink, in vertical and horizontal directions. So fill out those 3 things. I'd also like you to sketch y equals x squared after you do this scale change rule. So pick a couple points out from a basic y equals x squared graph, and then apply those, maybe just 3 to 5 points. Either 3 or 5 points is all you need. Make sure you include the vertex as well. And then use the rule and find the new shape and see what happens. Okay? And we will look at what you have in class tomorrow, and I'll talk to you later.